So a lot of the research I do walks the line between basic research and applied research. And applied research is really done to help society now. And so some of the information that I really focus on, like how do systems respond to disturbances, is important, especially for land managers, because they have to make the decisions on what to do once a particular disturbance has happened, whether or not they should interfere with recovery. And so some of the stuff that I do can give them an indication of whether they should interfere. And so some of the fires that I work in out west, one of the biggest issues that we can see, which will limit how quickly systems will recover, is how the size of large treeless openings that are created by certain wildfires. And so if I evaluate where the trees exist on the landscape using different detection techniques, then I can say, if you have a limited amount of resources to do any recovery efforts, you should do it in this location because it would give you the most benefit. It would enhance the recovery of the ecosystem the best. And so the research that I do can give land managers information about how to prioritize the resources that they have to make a significant impact. So this study actually led to the development of more landscape, wetland landscape type models. And so before, DACENT was really used for agricultural systems and forests, but it was really useful to use this model, making certain tweaks to it for wetland systems. And so they did come out with a wetland version that had even more modules in it that allows you to like model how water moves through a wetland system, which is quite important for how it's going to function. And so it really led to the development of wetland models, which is really important because if you look globally, there aren't that many wetlands. It's like 8 to 10% of land surface that is in the wetland state, but it has a significant amount of the global carbon in these systems just because they store and accumulate carbon so much. And so even though it's a small land area, they have a huge impact on global climate dynamics. And so now that there's all this interest in wetland model, and a lot of that is just because people are trying to adapt terrestrial models to wetland systems, now they're actually developing models that work best in wetland ecosystems. Yes, there were a lot of things. There are always a ton of things left unresolved for this paper. And so we could have taken all the possible futures and modeled them, right? And so if I had focused my entire PhD work on just this one chapter, then I really would have modeled all the possible futures to really get a good understanding of what the potential of these sites could be. But we just modeled 3 futures. And so it'd be interesting to know if the assumption that if you model the extremes and then the mid, that would give you an idea of what the possible futures are, but you don't know that until you actually go to model them. Mm-hmm. And so I think that would be a really interesting exercise to do, to see how well the assumptions line up with what would happen if we actually modeled the futures, if there would be any surprises there. Science is a tricky field. I think what happens is, like, if you're an undergraduate and you get into research and doing research, you start working with scientists, and then over time you keep working with scientists, and then you're like, oh, okay, I guess I'm a scientist now. And so that, to me, I feel like I got into science as an undergrad, working in research labs, and then I decided, oh, I should get a master's degree in science because that's what I was doing, and I really liked the work that I was doing. And so then I got a master's degree, and then when you go and you present your research different places, you get a lot of opportunities to keep working in science. And so I just kept on going, and after my master's degree I got an opportunity to pursue a PhD project, and then did that and still loved research, and so I just stayed in it. You know, it just takes over your life. Okay, so I decided, based off of me and what I like, that I always knew natural resource type projects were my thing. And so because of that, that removes like health sciences, because people aren't my favorite. And I don't want to work with them. And I especially don't want to work with sick people. Like, oh. And so I knew, like, you know, medicine and things like that, that's not really for me. And so my next avenue was really plants, because I also know, I mean, I like animals, but I didn't really want to work with animals or, you know, anything that could eat me. And so plants were my thing. And so I really focused on research opportunities that included getting out in natural systems. And it will push you in two general directions, I think. Natural resource management, which I did do a little bit of that as an undergraduate and through internships, or it'll push you into strictly research type positions. And so I did like the management stuff, but I liked it because I got to apply some of the research techniques that I had also been studying. And so I did a bit of both, the applied and then the basic research, and the basic research one. My research, I think one of the best things that was told to me as an undergrad was that when you decide to become a scientist, you have to commit to doing something different than everyone else. And so back in those days, what I could tell was different than other people who were doing a lot of the natural resource focused stuff was there were not that many people doing a lot of quantitative research, and there weren't a lot of people working at the intersection of information science, remote sensing, and using all these different techniques. And so I thought that to make myself different and stand out, I should work across these different techniques to do studies. And so I shouldn't just choose remote sensing and only do remote sensing. I shouldn't just choose eddy covariance fluxes and only do that. I decided to work across a bunch of different techniques and fields. And I think that that has worked out for me quite well, especially because during that time, there has been a shift in ecology from a very descriptive science to a very quantitative science. And because of that, there is a huge need for you to be quite quantitative. And before, the level of information and statistics that you would need as an ecologist was just much lower than it is now. And so it was a really good move to be more on the quantitative side of things. And so you young people will see that almost anything that you go into, you're going to have to be quite good at math and statistics. Like, there's no way around that anymore. That's in the past. Just be clear about what you're reading the paper for. Right, and so you'll see that a lot of the scientific articles, they're really long, and we have to stay up on the latest information. And to me, like, the best way to do that is to read the most interesting part of articles, and I only get into the nitty-gritty of the methods when I need to. Like, when I need to replicate what they're trying to do, and that's when I'll get myself all drawn into their methods. But before then, if I'm just reading it for entertainment, I just read the abstract to see how interesting it is. And from the abstract, if I decide, oh, this sounds cool, then I'll go into reading the intro, the results, and the discussion. Yeah, I would just say take the time to explore research opportunities where you are, because one, you're at a Research One university, so there are a ton of research opportunities. to try the things that you think you like, and then try a few of the things that you think you won't like, because your understanding of certain fields might lead you to think something isn't right for you, but once you try it, you might feel very differently. And it's really important too, because when you think about it, there's a huge number of you guys who will graduate and not work in your field. And that's because you didn't choose the right field. Right? You didn't choose the right field, and you didn't figure out all the great possibilities that you could do with that field. You have to find something that you're passionate about if you want a job that you like. You know, and so that takes a lot of work and effort, and to find the thing that you're passionate about will require you to try all these different things that you're not going to like. Right? And so that's what you're looking for, is like, what are some of the things that stand out? What am I actually good at? You know, that's outside of school work. It's not going to be obvious to you by you reading something once. Like, you really have to go out, get in a lab, and say, can I go out with you? Can you take me out in the field? You know, what can I do? And that's the only way you're going to know. Yeah, and so if you notice, when you guys are reading these papers, very few of them have one name on them. Right? And so students like look at us with those death eyes when we assign them to group projects, thinking like, oh, this isn't how the real world works. It is. That's how the real world works. We do things in groups. And so if you decide that you want to do a paper, I would say the first thing you want to do is think about, once you've identified what your question and what your study is going to be, think about who could help you, who would be a good group to write this paper with you, because that is going to make or break the process. It will be a fun process, or it will not be so much fun. It's the same as a group project. You choose good people in your group, you're smooth sailing, and it's great and it's enjoyable. You choose some people who are not that helpful, or who don't have the specialty that you need to actually do the work you want to do, and it will not be smooth sailing. You'll be asking people to do things that are outside of their specialty. Some people are okay with that, some people are not. And so it could be a good process or a bad process. It depends on your ability to recognize what you need to do, and then who can help you do that. And so choose your group.